Jupiter is the largest planet in our solar system. It is a gas giant with a swirling atmosphere and a faint ring system. Jupiter has many moons. In fact, astronomers are constantly discovering new ones. In 2018, a team of astronomers found a tiny moon orbiting Jupiter. They named it Ersa. Ersa is very small, only about 2 miles across. It is much too faint to be seen with the naked eye. Even with powerful telescopes, Ersa appears as a faint dot of light. The discovery of Ersa reminds us that there is still so much to learn about our solar system. Discovering a tiny moon like Ersa is no easy feat. It requires powerful telescopes and a lot of patience. The team of astronomers who found Ersa used a telescope called the Victor M. Blanco telescope. This telescope is located in Chile, South America. The astronomers took many pictures of Jupiter and its surroundings over several months. They then used computers to compare the images. By looking for tiny dots of light that moved in a pattern, they were able to identify Ersa as a new moon. Ersa is not alone in its journey around Jupiter. It belongs to a group of moons called the Himalia group. These moons are named after Himalia, the largest member of the group. The Himalia group moons are all thought to have a similar origin. Astronomers believe that they are remnants of a larger moon that was shattered long ago. The moons in the Himalia group share similar orbits and have a grayish color. Ersa orbits Jupiter at a distance of about 7 million miles. It takes about 250 days for Ersa to complete one orbit around Jupiter. Like other moons in the Himalia group, Ersa has a retrograde orbit. This means that it orbits Jupiter in the opposite direction to the planet's rotation. Ersa is a very faint object. Astronomers estimate that its surface is very dark, reflecting only a small amount of sunlight. The exact composition of Ersa is unknown. However, based on its color and the composition of other Himalia group moons, it is likely made up of rock and ice. Section 5. A name from myth, Ersa's story. When a new moon is discovered, it is given a temporary designation. This is a code that identifies the moon and its year of discovery. Once the moon's orbit is confirmed, it is given a permanent name. The International Astronomical Union, or IAU, is responsible for naming celestial objects. The IAU has rules about naming moons. Moons of Jupiter, for example, must be named after characters from Roman mythology. Ersa is named after a Greek goddess who was the daughter of Zeus, the Greek equivalent of Jupiter. Ersa was a goddess of dew. Section 6. Jupiter's pull. The dance of gravity. Ersa's orbit around Jupiter is not perfectly circular. It is slightly elliptical. This means that Ersa's distance from Jupiter varies slightly as it orbits the planet. The gravity of Jupiter and its other moons constantly tug on Ersa. These gravitational forces cause Ersa's orbit to change slightly over time. This is a common phenomenon in astronomy. The orbits of most moons and planets are affected by the gravity of other objects in their vicinity. Section 7. Exploring the unknown, future missions. While we have learned some basic facts about Ersa, there is still much that we don't know about this tiny moon. This enigmatic celestial body, orbiting Jupiter, holds many secrets that scientists are eager to uncover. Despite our advancements in space exploration, Ersa remains largely unexplored, and its mysteries continue to intrigue astronomers and researchers alike. Its exact size, shape, composition, and surface features remain a mystery. The moon's surface could be covered in ice, rock, or a combination of both, and understanding its geology could provide insights into the history of the Jovian system. Detailed studies of Ersa's surface could reveal clues about the processes that shaped it and the potential for past or present geological activity. Future space missions could provide us with more detailed information about Ersa and other small moons in the outer solar system. These missions could be designed to map the surface of Ersa in high resolution, analyze its composition, and search for signs of any geological processes. By sending advanced spacecraft equipped with the latest technology, we can gather data that will help us understand these distant worlds better. These missions could involve sending spacecraft to orbit Jupiter and its moons. By placing a spacecraft in orbit around Jupiter, we can conduct long-term studies of Ursa and its neighboring moons. This would allow us to observe changes over time and gather comprehensive data on their environments. Such missions could also include flybys of other moons, providing a broader understanding of the Jovian system. These spacecraft could be equipped with cameras, spectrometers, and other instruments to study the moons in detail. High-resolution cameras would capture detailed images of the surface, while spectrometers could analyze the composition of the moon's surface and atmosphere. Other instruments could measure magnetic fields, radiation levels, and other environmental factors, providing a comprehensive picture of these distant worlds. By studying these small moons, we can learn more about the formation and evolution of our solar system. Understanding the characteristics and history of moons like Ursa can provide valuable insights into the processes that shape the planets and moons we see today. This knowledge can also inform our search for life beyond Earth, as we learn more about the conditions that might support life in other parts of the solar system. Section 8. The significance of small moons. Although small moons like Ursa may seem insignificant compared to the gas giants they orbit, they play a crucial role in our understanding of the universe. These celestial bodies, often overlooked, are like time capsules that hold secrets of the past. They are remnants from the early solar system, providing a window into the conditions and processes that were prevalent billions of years ago. They provide clues about the processes that shaped our solar system billions of years ago. By examining their surfaces and compositions, scientists can infer the history of planetary formation and the dynamic events that have occurred over eons. These small moons are like puzzle pieces that, when studied collectively, help us complete the picture of our solar system's history. By studying the composition and distribution of these small moons, we can gain insights into the conditions that existed when our solar system was forming. The materials found on these moons can tell us about the primordial matter that coalesced to form planets and other celestial bodies. This information is invaluable for constructing models of solar system evolution and understanding the diversity of planetary systems in the universe. Furthermore, these small moons could potentially harbor valuable resources. Elements such as water ice, metals, and other minerals could be extracted and utilized for various purposes. Water ice, for instance, could be converted into oxygen and hydrogen, providing life support and fuel for space missions. The economic potential of these resources is immense, and they could play a pivotal role in the future of space exploration and industry. As we continue to explore space, these resources may become increasingly important for future space missions. Establishing a sustainable presence in space will require the utilization of local resources to reduce the dependency on Earth. Small moons could serve as refueling stations or supply depots, supporting long-duration missions to distant destinations. Understanding the composition and distribution of resources in our solar system will be crucial for sustaining human presence beyond Earth. As humanity sets its sights on Mars, the asteroid belt, and beyond, the knowledge gained from studying small moons will be instrumental in planning and executing these ambitious endeavors. The significance of small moons extends far beyond their size, offering a wealth of information and resources that could shape the future of space exploration. Section 9. Conclusion. Ursa's place in the cosmos. The discovery of Ursa is a testament to the power of human curiosity and our relentless pursuit of knowledge. It represents a significant milestone in our journey to understand the universe. The process of discovering Ursa involved countless hours of observation, data analysis, and collaboration among scientists from around the world. This tiny celestial body, though seemingly insignificant in the vast expanse of space, holds valuable information that can help us piece together the history and evolution of our solar system. Despite its small size and distance from Earth, Ursa has captured our imagination and expanded our understanding of the cosmos. Its discovery has sparked new questions and theories about the formation of moons and other celestial bodies. Scientists are particularly interested in studying Ursa's composition and orbit, as these factors can provide insights into the conditions present in the early solar system. The more we learn about Ursa, the more we realize how much there is still to discover. As we continue to explore our solar system and beyond, we are sure to uncover even more secrets hidden among the stars. Each mission, whether it involves sending a spacecraft to a distant planet, or analyzing data from telescopes, brings us closer to answering fundamental questions about our place in the universe. The exploration of space is a continuous journey, one that requires innovation, perseverance, and a willingness to venture into the unknown. Ursa serves as a reminder that there is still so much to learn about our universe. It encourages us to keep looking up at the night sky with wonder and curiosity. The study of Ursa and other celestial bodies not only advances our scientific knowledge, but also inspires future generations of astronomers, engineers, and explorers. It is a symbol of the endless possibilities that await us in the cosmos. Each new discovery brings us one step closer to unraveling the mysteries of the cosmos and understanding our place within it. The journey to uncover these mysteries is a collective effort that unites humanity in a shared quest for knowledge. As we continue to push the boundaries of what is possible, we are reminded of the vastness of the universe and the endless opportunities for discovery that lie ahead. Ursa, like many other celestial discoveries, is a beacon of hope and a testament to the enduring spirit of exploration.